Welcome in our mathematics class of where we are continuing with algebraic techniques. Now, previously, we have looked at the number patterns, we have looked at sequence, we have looked at spatial patterns, and we've seen how to relate the spatial patterns and the number patterns. Now, today, I want us to look at the tables and rules. And this one is developed from what we just went through earlier on in our previous class about spatial patterns. Now, you will realize that in this section, we are going to now concentrate on the rules. And then we extract a table, and this table will guide us. But before that, let us look at what we had initially. And what we had initially, we were looking at spatial patterns, and we would have, for example, if we can take, this is a diamond, symbol of diamond, represented by sticks. And then the third one, now, when you look at this, we have a diamond represented by 4 sticks. Then we have a diamond represented by 8 sticks because we have quite a number of it. And the third one is here. Now, you will notice this. You will notice that one diamond has been produced or has been used by total of 4 sticks. One diamond has used 4 sticks. 2 diamonds has used 8 sticks, and the 3 has used 12. Now, this is just to show the information we have here can be tabulated, and when we tabulate this information, then we shall be generating what we call tables and rules. You realize that in this case, we can have number of diamonds, and number of sticks, number of diamonds, and number of sticks. So one diamond here, if you can see, has got 4 sticks used. And this one can be seen that for 2 diamonds, we have 8 sticks. From our diagram, 3 diamonds, we have 12. Now here, we have the number of sticks is equals to the number of diamonds multiplied by the number of sticks per each diamond. I'll repeat. The number of sticks for every pattern is equals to the number that makes one diamond, in this case 4, multiplied by the total number of diamonds. So here, we consider the following. We consider the following. we shall consider that the diamond is taken to be our input, while our output is the number of sticks. Because we are looking at it, for us to get the total number of sticks that is making up these diamonds, it is our output. That's why I say it's equals to the number of sticks multiplied by the number of the diamonds. So we say here that we have here, in this case, we have, for example, 2 diamonds. 2 diamonds, it's 4 sticks times 2, where 4 sticks is for 1 diamond, and then the second one is multiplied by 2. So to get this 8, we took 4 sticks multiplied by the number of diamond, which is 2. That is how we arrived here. And that is the rule that has actually guided this table. So we can simply say that, we shall get back to this table. You can say that output, and when I talk of output, is the total number of sticks that makes the diamond in this case. Output is equals to, we have 4. This 4, you realize that it stands for the number of sticks that was making 1 diamond. Then we multiply by the input, and the input in this case is the number of diamond. So this is just a formula that is going to be used as we go about the tables and the rules. Now, when we talk about rules, what are we actually referring to? A rule shows the relation between 2 varying variables. The table we are talking about has got a rule, and the rule here shows the relationship or the relation that is there between 2 varying variables. And if you are keen here, for example, what the example we went through, we had input and we had output. Those are variables. So we can simply have an example, like we can say output is equals to input plus 3. This is a rule. It is showing us the connection of input and 3 to give us the output that we intend to have. So this input and output can always vary. They can always vary, but you must know that the rule, we must know from the rule that output will always, in this case, as much as variables here will vary, we must know that output will always be 3 more than the input. That will remain constant across all the variables. So output will always be 3 more than the input. And that one only applies in this rule that we've written here. It is not the only rule. The rules keep on varying, as we shall go and see as we move ahead. Then we have a table of values. A table of values. This is a table that can be created from any form of rules. So a table of values is a table that can be created from any given rule. Like the rule we have here, it can give us a table. It can give us a table where we have the output and we have the input, and it will give us a table. So any table that can be created as a result from a rule that we have been given, that table is what we call a table of values. Now, the table of values needs to be completed. And for us to complete the table of values, we need to have these values substituted. When you substitute, you will always find out the results. If you substitute the value of input, definitely you'll get what the output is. So this table needs to be completed. And if we have to complete, then one of the variables or the value must be known. For example, then if we know the input, we shall get the output. If we have the output, we can always get the input. So one of the varying quantities must always be known. And when we say that process where we are now substituting in or replacing the value of a variable is what we call substitution. Is what we call substitution. So after substituting, for example, in an input, then output will always be gotten. When you substitute a value in a quantity, in a variable that varies, then you'll always have the results of the other. Now let us look at the example that we have, this example here, and see how it will work on this. If we take input in this case to be 4, then by substitution it will mean output is equals to input plus 3, but input is 4. So giving that input is 4, we substitute input and write 4, then add 3. When you add 3, you'll get that the output in this particular case is equals to 7. So if the output is 7, then we are able to get 7 based on the fact that the input was 4. Now, we must observe the rule and maintain it without changing while we are carrying out the substitution. Don't we change here and say, now, let the sign of operation change. The rule must be observed. Now, we want to take a close inspection of values while generating a table of values. Now we have a table of values. This table of values needs to be inspected. I want you to take a closer look of the values of both input and output. What do you realize? What do you discover? Now from this, you realize that the output is 5 more the output is 5 more than the input. How? Let's see. 1 and 6. 6 minus 1, it's 5. 7 minus 2 is 5. 8 minus 3 is 5. 9 minus 4 is 5. 10 minus 5 is 5. And 11 minus 6 is 5. So we can, by inspection, we can develop or generate a rule and we write it down. So what rule are you discovering by inspecting this table of values? The rule here is that output is equals to input plus 5. Output is equals to input plus 5. So we are learning that you may have a table, then you come up with the rules. Or you may have a rule and you come up with a table of values. Either way, we should be able to get to the other. So when we have the table of values clearly put down, it's your duty to inspect and identify the values, substitute in and find the output. Then from there, inspect it and come up with the rule. So let us look at some of the exercises and examples that we apply these tables and rules. We shall handle each question as it comes. Complete each table for the given rule. And the rule here is output is equals to input minus 2. Input minus 2. On the table of values, we have been given the values of input. But on output, we do not have the values. So they are asking us, using this rule, fill this table. So we simply come and start working out by replacing this. The first value, if output is input minus 2 and input is 3, so we want to substitute here. If it is output is equals to input minus 2. Substitute the value of input with 3. It will be 3 minus 2, which is equals to 1. So you find that this part is 1, For the second part, by substituting, it is 2, input is minus 2 and input is 5, minus 2, then the answer here is 3. So I'll expect us to have 3 there. And so on. The rest we can do it offhand mentally. 7 minus 2 is 5. 12 minus 2 is 10. And 20 minus 2 is 18. What we have here is simply the table of values given by the output is equals to input minus 2. Now, let us look at a different, still want to fill a table, but this time now with a different rule. Output is equals to 3 times input Now here, using the rule output is equals to 3 times input plus 1. 3 times input plus 1. Fill in the table. We have seen rules when you are adding. We have seen rules when you are subtracting. This time our rule is input multiplied by 3. So to resolve this and fill in the table, we find that our value of output will be equal to, now we have 3 multiplied by input. And then this one, you add 1. It's very important to observe our brackets so that we are always aware of what should be worked on first before the other. By substituting the input by either 4, 2, 9, 12, and 0, you'll find that when the input is 4, then we shall have this as 3 multiplied by the input, which is 4, close the bracket, plus 1. 4 times 3 is 12, plus 1, this one gives us 13. So I expect the value here to be 13. The second one, again, we shall use the same principle. Output is equals to 3 multiply by input, and input is 2, then plus 1. So substituting 2 where we had the input. So output becomes 6 plus 1, which is equals to 7. So the value here is 7. The rest you can do it offhand and see what you are getting. For 9, it is 3 times 9, which is 27. 27 plus 1 gives us 28. Next is 3 times 12, which is 36, plus 1, which is 37. And the last one is 1, because 0 times a number is 0, plus 1 remains 1. That is what we have. These are the values that are missing, and these are the varying variables and values for the output. Now let us see. We have used a rule to develop a table of values. Now we want to look at the table of values, and then we come and develop a rule. Find the rules for each of these tables of values. The rule is not known, but the table has been drawn, which means the values for the output are clear, and the values of output are as follows. Now, what could be the possible rule? This is done by inspection, by trying one or two other methods. Relationship between the output and the input on all the variables must be a constant. So from the first one, you realize that if you look at the input and output, we want to find out output is equals to what? It should be equals to input. And then from the input, put something, either to minus, to add, or to multiply. When we look at this, you realize that there is some tendency of a constant common difference. And if you look at it very well, it is an addition of 9. There is an addition of 9. Now, if that is the case, let us see. Is it applying in all? 12 minus 3 is 9. 13 minus 4 is 9. 14 minus 5 is 9. Therefore, 9 is a common difference. Therefore, we can now bring the rule. The rule is 3 is the input. For each area we would fill rules, plus the common difference of 9. Why this becomes the rule? It is because at any given point where the input is varying, there is a constant increase of 9 to arrive at the output. Now, next table. Now we have the question for the table that we have. Find the rule that dictates the flow of information on this table. By inspection still, you look at the values, you look at the behavior, how is it you're arriving at another one and you see. What do you get? Now, there is some possibility that there is some relationship here. 1 and 7. 1 to arrive at 7, you can either add 6. So if we say plus 6, 1 plus 6, just look at this. Somebody will say this is plus 6. So 1 plus 6 is equals to 7. Fine. Suppose if you take 2 is 2 plus 6 equals to 14. This is wrong. So by inspection, this method is not working when we subtract. We look for alternative method. One multiplied by 7 is 7. This is the input, this is a constant, and this is the output. Let's try the next column. 2 multiplied by 7 is 14. Let's try the fourth one. 4 multiplied by 7 is equals to 28. So this is correct, this is correct, this is correct. Both the 3 are correct. And if the 3 are correct, then there is a rule being developed. You will notice that each input value has been multiplied by 7 to arrive at the output. Therefore, we can write our rule and say that output is equals to 3. Output is equals to, we are looking at the self, is equals to the 7 multiplied by input. 7 multiplied by the input. This is our rule. Now, you should have realized that when dealing with the tables of rules and the issue of the tables of values and the rules, you should have noticed that the principles or the skills we learned in number pattern is still remaining to be observed. Why I'm saying that? It is because for us to get a value, we need to study the table. We look at what is the possible outcome and what has happened to the input to arrive at the outcome. And that simply means you study the pattern, how it is flowing, and identify. Are you going to work out by looking at the common difference, by looking at the common ratio, by either looking at a special kind of information that we can use to get the next term or so. So we need to maintain that the knowledge we learned previously is very important on this topic as we go on. Now, we can be given various tables, and then we develop the rule, or we can be given statements and then we confirm whether the statements are true or false. So in the following question, I want us to simply do it, and as we do it, we tell whether it is true or whether it is false. let us look at those first and then we bring in others later. State whether the following statements, the following statement is true or false. Our first statement says, if output is equals to input times 2, then when the input is 7, output is 14. We need to find out. We need to substitute and see. Output equals to input, the first one, is equals to input multiplied by 3. They are saying that 7, because that is the value of the output here, this is 7. Now, if this is 7, is it true that 7 is equals to? Is it true that 7 is equals to, 7 is our output, not our input. Is it true that output, which is 14, is equals to 7 multiplied by, sorry, this is not for 3. We are looking at 2. Output equals to input times 2. That's what you are, what the rule is. Is it true that 14 is equals to 7 times 2? If 7 times 2 is 14, then which is the case in this particular case, we can simply come and agree that this statement is true. The second statement, it was saying on output is 7. The second statement, is it true? Because the statement is saying that if output is 2, if output is equals to input minus 2, and if input is 5, then output is 7. So we start by output, which is 7, is equals to input. Input is 5 minus 2. Minus 2, you find that 7 is equals to what? 5 minus 2. And 5 minus 2 is equals to 3. So 7 is not equals to 3. So we can say that the statement here is false. The statement there is false. So we are only inspecting. We have a statement and then we inspect it and see whether it's going to give us the truth or not. Input was 5 minus 2, which then 5 minus 2 is 3, but not 7, as we have been told in this particular case. Now, on this table, we are to complete the table for the given rule, and the rule is output is equals to input multiplied by input and then minus 2. Output is equals to input times input minus 2. So this case, we have 3. We work it out by substitution. And when we work out by substitution, you find that when the output here for the first part is equals to input, which is 3, times input, which is also 3, and then you minus 2. The rules of order of operation says that multiplication and division is first done starting from the left, and then we finish with the other. So in this particular case, it is 3 times 3, which is 9, minus 2, giving us 7. So the first box can be filled with 7. Second box, it is going to be 6 times 6 minus 2, which is 36, minus 2, which is 34. 6 times 6 is 36, minus 2 is 34. So second part, we have 34. 8 times 8 is 64, minus 2 is 62. We have 12 times 12 is 144, minus 2 is 142. And finally, 2 times 2 is 4, minus 2, giving us 2. So from this, we have established and used the rule to fill the table of values without actually struggling, because it's a matter of substitution. Now, let us look at the situation of an operation or a rule with a quotient or with a division. Now we have a rule here that output is equals to 24 divided by the input and then plus 1. 24 divided by the input and then plus 1. The input we have 6, 12, 1, 3, and 8. Output, we don't have the values, but we want to use the rules that we have to fill this table correctly. So on the table, we need to first see, this is the rule. So output is equals to 24 divided by input, and input here is 6, and then we add 1. This one is divisible. 24 by 6, you'll get 4, plus 1 gives us 5, so the value here is 5. 24 divided by 6 is 4. 4 plus 1 is 5. We can look at the second variable, and the second variable, you find that we have output is 24 divided by the input, which is 12, and then we add 1. This one becomes 24 divided by 12 is 2 plus 1, this gives us 3. So we can comfortably fill the content as 3. 24 divided by 1 is 24 plus 1 is 25. 24 divided by 3 is 8 plus 1 is 9. And 24 divided by 8 is 3 plus 1 is 9. Sorry, 24 divided by 8 is 3 plus 1 is 4. 24 divided by 8 is 3 plus 1 is 4. 24 divided by 3 is 8 plus 1 is 9. 24 divided by 1 is 24 plus 1 is 25, and this one is 3 and 5 respectively. So we have been able to fill this table by observing the rule that we have above. Now, in the case of this table, sometimes we even have tables, but we don't have the values. In such situation, you should not panic because maybe you have been given letters or we have the rule with the funny letter tables. No, the rule always remains the rule and a variable remains a variable. When you substitute, you should have what you need. Let us look at the next question again. Now, this one, we are going to have a table, but we shall not have figures or values the way we have always had. But want to see, does the rule also apply when you have pronumerals? So, complete this table. The rule is output is equals to input plus 6. The table we have C, D, 2P, B squared, and W, W, W. Now, these are just values. These are just letters. But the rule must be observed. So, in this case, for the first one, we shall find that our output is equals to input. Input is C plus 6. So it cannot be simplified further, which means if there is a possibility of simplification, simplify. So this one here, it will remain as C plus 6. C plus 6. For the second one, it is input, which is D, plus 6. The other one will be 2P plus 6. B squared plus 6. W plus 6. Now, in such situation, if there will be anywhere that you find requires to be simplified, kindly make sure you simplify your values. Otherwise, if there is no place to simplify, you maintain it as it is. Let us look at another table. I think the last example of this. And for the last example here, again we are going to look at these values but with a multiplication or a product of letters. Now the rule has changed. We want to look at an example where we shall have multiplication also. So the rule here says 3 times input minus 2. Quite tricky. The values are t, k and p squared, f and AB. And then we need to fill in. We need to use the rule. Take note that output here, as we solve this, output is 3 times the input. Input is t, and then you do what? You minus 2. As we learned earlier on, when we have a number multiplied by a pronumeral, which is the same as just saying 3t minus 2. So this is what we have simplified, and that is what will be the value of output here is 3t minus 2. For the second one here, it is k. Output is equals to k times 3, so it is 3 times k, and then all of this you minus 2. This one gives us 3k minus 2. The next is p squared. P squared times 3, and then minus 2. This one will give us 3p squared minus 2. And if we do that, this is 3p squared minus 2. We have 2f. For the 2f, we have 3 multiplied by 2f into bracket minus 2. Now this one, this is a number and a number, it can be multiplied. So 3 times 2 is 6, giving us 6f minus 2. This one is what we have. So we shall write there, this will be 6f minus 2. And the last one, 2ab, twice ab will give us ab. 2ab is just 2ab minus 2. So this will be 2ab minus 2. Now, this is how we fill a table of values given that the input is not figures, but they are in numerals. In our next class, we are going now to extend this into a more detailed information and start working on what we call Cartesian planes and graphs. I expect you in the next class to have graph books or graph papers. Make sure you have a good pencil so that we shall be able to construct and show what a Cartesian plane is. That is the end of our class. Thank you.